Hey there, Hampshire chemistry students. Today we're going to be taking a look at finishing up our half-life lab together. So make sure you've got this guy out in front of you. Now you should have a couple things done already. We should have our data collected and our percents calculated. But what we're interested in here today is making sure that everybody has their graph finished for their half-life graph. We plotted the years that were taking place and the average percentages of our class. You should have ended up with a graph that looks something like this, right? You're plotting your points, and then what we're going to do is we're going to connect all of our points in a nice, even line. You can see this nice decay as the graph goes down. And what we want to do today is kind of make sure we understand what this means. Because we were discussing the idea of half-life. Okay? Half-life is, when we talked about this at the top of the video, half-life, remember, is the amount of time it takes for half of a sample to decay. If you don't have this written down, make sure you have it written down right now. So we're focused on the amount of time it takes. So let's look back at the graph and see how long it takes for half of the time to decay. We start out at 100%, and if we're at 100%, the first half-life would be, well, at 50%. Well, if I just went through my first half-life, my second one, half of 50, that would be at 25. So this would be my second half-life. Well, if let's say I went through one more, a half of 25, that's going to be about 12, and that was my third point here. Remember, each one of these guys is representing the decay of our different elements. So let's say I started off with like 8 blue dots here. They represent the SR90. Okay? We're going to start that off at the 100% up here. I have 8 blue dots. Okay? If I'm going through my first half-life, half of those 8 blue dots, so 4 of them, are going to become what it broke down into. In this case, that was the Y90, the yttrium 90. But we still have 4 of the SR90 left over, right? Half have decayed. If I looked at my second half-life here, another half would have decayed. So half of my remaining blue dots would have decayed. So half of the 4 would be 2 more. So I'd have 1, 2, 3, 4, 5, 6 that have now decayed, and 2 that are still left over, right? We went 8 blue dots to 4 blue dots to 2 blue dots, half the time. But hey, look, we started here with 0 red dots. Here we went to 4 to 6. So this is a relationship here that as we lose the SR90, you are gaining the opposite, the decayed piece, the Y90. So let's write that down here. So as you lose the SR90, you gain Y90. That's going to be super important as we go through and answer some of our questions. That as one of these is going down, that means the other decayed piece has to be going up. You're going to use this graph to help you answer the questions on the previous page. Okay, questions 2, 3, 4, and 5, you want to use your graph to help you answer. Okay, one hint here that can help give you might be some trouble is number 4 talks about your Y90. Remember that this is the opposite of the SR90. So this is the guy that's being created when we are losing the SR90. So make sure you think carefully about number 4 as you're working on it. So lastly, we do have some questions on the very back here. You have a graph that's provided for you for a chemical called carbon-14. On some of these questions, you're going to have to use the graph. Like number 6 asks, based on this graph, what is the approximate half-life? So just like we did on the previous question, you can start up here at 100. If you're at 100, you're going to go to 50. And I can figure out, hey, what time would I expect to be? That is your half-life time. Okay? I'll let you guys make the estimate there, but what you think makes the most sense for that first half-life. So make sure you're taking some time on this. Use your graph to help you, and you will do awesome. Okay? Have a great rest of your day.